right, so if you want to know what the sine of half of an angle is, you can use a half angle identity formula. For example, I can't find the sine of 75 on the unit circle, but I could rewrite 75 as what number divided by 2? What number divided by 2? 150 over 2 is the same as 75. So up here, let's just write that thought down. 75 degrees is equal to 150 divided by 2. So I can rewrite sine 75 as sine 150 over 2. And now this looks like my half angle formula, so I can change it from the left side to the right side. So I have a plus or minus, big square root, 1 minus cosine theta. Now that theta is the number that is on top of the 2, this number. So this number goes right here. And then over 2. Now this is a new formula, guys. It's on your calendar, but we haven't used it before. So I don't know the sine of 75, but if I rewrite it this way, now I only need to know the cosine of 150. All right, so think for a minute what the cosine of 150 is and tell your group. Okay, what is cosine of 150? Negative root 3 over 2, good. So I evaluated cosine 150, and your classmates told me it was negative root 3 over 2. Oh yes, let me just zoom out. There we go. All right, now the plus or minus, guys, it's not plus or minus like in the quadratic formula where it's both. It really is either plus or minus, but there's an easy way to figure it out. Go back to your original problem. In your original problem, you're trying to find the sine of 75, and 75 is in which quadrant? First. So in the first quadrant, is sine positive or negative? It's positive. So that sine right there depends on the sine of 75. So sine is positive in the first quadrant. Okay. So sine's positive in the first quadrant, so we're going to go with the positive. You can write the positive, or if you leave it off, then that's just positive automatically. So now we have to combine so that we don't have a fraction in a fraction. So I need to combine these two with a common denominator. So what can I multiply the 1 by?
2.
Over?
2.
2 over 2, yeah. So this is going to give me 2 over 2. Instead of minus negative, what can I write?
Plus.
Plus root 3 over 2 over 2. All right, so I have divided by 2, divided by 2. If I want to change this to a fraction and multiply, I change it to times what fraction?
Is it 1/2?
Yeah, I'm going to do times 1/2, that's right. So I have this 2 plus root 3 over 2 times 1/2. So dividing by 2 is the same as times 1/2. So we do end up with a radical and a radical, which is not pretty, but there's one thing we can do, which is rationalize our denominator. So if I have square root of 4 in my denominator, that becomes what? 2. So what we're going to do is we're going to take our square root, put it only on the numerator, and then change square root of 4 to be denominator. Okay, so notice my square root's now only on the numerator, and I do have a rational denominator. It's the least I can do if I'm going to have a radical and a radical, which is not super fun.
Can you make it a
No. It just has to stay like that. All right, so now we're going to do the same thing with cosine 75 degrees. It looks a lot alike because look at your cosine formula. What's the difference between your cosine theta over 2 and your sine theta over 2 formulas? Yeah, it's just a plus instead of a minus. So really, along the way, things are going to look quite similar. All right, plus or minus square root 1 plus cosine 150 over 2. Oh, and that's because, sorry, I didn't look at the formula down here. I'm skipping ahead. This is going to be cosine of 150 over 2. All right, so now I'm here, and I do the same steps as before. So cosine of 75 is positive or negative? It's positive, good. So you're going to keep the positive again. That's not always true. Sometimes it's going to be negative. So I'm going to have 1 minus root 3 over 2 over 2. So it looks a lot like this. It's just the opposite sign. So really your steps are going to be exactly the same. Your 1 will become 2 over 2, so you can combine them. Yeah.
I have a question. So for this step here, if you're changing it to multiplication, isn't it multiplied by 2 over 1?
A lot of people have that same misconception. Think of this 2 here as being the 2 over 1. So when you change it to multiplying, it's times 1 over 2.
Yes, no, it's one of these things.
All right, so our answer is looking really familiar. Big square root, 2 minus root 3 over 4. And in your final answer, you just want to rationalize your denominator by multiplying, not by multiplying, by taking the square root of 4, and you get 2. So 2 minus root 3 over 2.
Okay.
All right, so you can use half-angle identities to find trig values for angles that aren't on the unit circle. We could have, yes, who's that? Yes.
So if you're multiplying by 1/2, so that's why it's like 2 minus root 3. But what if you had like 5 over 2? What would you multiply the 5 by? Like the 2 or the root 3? Like, do you know what I'm saying?
So if this was 5 minus root 3 over 2?
No, okay, so do you see how you did the 2 minus root 3 over 2 times 1/2?
Yes.
If that was like a times 3 over 2, like how did your answer change? Like where would, like, by what would you multiply the 3?
So if this was a 3 here, I would distribute it to the 2 and to the root 3, so it would be 6 minus 3 root 3.
2 minus.
So if I had a 3 here, I would multiply it here and here. I'm not going to have a 3 though. It's not going to happen.
It's always going to be 1/2.
Well, it's always going to be 1 over something there.
But I think she's saying, like, do you have to multiply into the entire, you know how, like, usually you
Distribute?
yeah, well, you have
Yeah.
to distribute, like,
Yeah.
you know, there's like a 3 outside, and then you
Yeah.
have to, like,
All right, hold on, guys. I'm going to pause for a second, and I'll take some more questions. All right, so here we go. This is the problem I just gave you, cosine 157.5. So Ina rewrote it as 315 over 2. And then she used the formula 1 plus cosine theta over 2 square root plus or minus. Cosine 315 is root 2 over 2. And changes the 1 to 2 over 2, combines into 1 fraction, and then changes divided by 2 to times 1/2. So then you have a 4 in your denominator, but the square root of 4 is 2. Now, take a look at her signs. Oh, sorry, all the way down. Take a look at her signs all the way down. She's got plus or minus, and then she finally chose minus. And she wrote a little note at the top to help you. Yeah. Think about what quadrant this number is in and if cosine is positive or negative in this quadrant. So 157.5 is which quadrant, guys? No, 157.5, guys, this number. It's in 2. Good. Cosine is positive or negative in 2?
So it's negative, right?
It's negative, yes. Okay? So this answer out here is negative.
Wait, is it the quadrant the original angle is in, or the one we're dividing by 2?
Good question. All right, guys. Delaney asked a good question. Quiet down. She wants to know, are we talking about the quadrant that the original angle is in or the one that was double? We want the cosine of 315 for this number. So the cosine of 315 is positive, so that one's positive. But for the outside, we want the cosine of 157.5. So we need to worry about the quadrant that's in for that. So there are 2 different signs you're worrying about. All right, I want you to turn the page, and we're going to look at the next side. All right, on the back. How many formulas do we have for tangent theta over 2? 3 formulas. Which one do you think is my least favorite? I'm on the back.
The first one.
The first one is my least favorite because I prefer not to do a square root if I don't have to. Why might somebody want the first one though? In what cases would they want the first formula instead of the second and the third?
They have.
Yeah, if you only have the cosine and you don't have the sine, it's possible that you would want one of these formulas here, okay? But in my example, I only have the sine, so let's figure out how we're going to deal with that. So I have the sine, and I know what quadrant it's in, so what do you think I'm going to do? But how can I find the cosine? Draw a triangle, draw a picture, I heard. Yes. So we're going to draw that in the first quadrant because it's between 0 and pi over 2. So here's my theta. The sine would be the opposite over the hypotenuse. So opposite is 7, hypotenuse is 25. All right, this is another special triangle, but if you don't know it, you got to do a little bit of math. You got to do 7 squared plus x squared, yep, equals 25 squared. 49 plus x squared equals 625. X squared equals 576. And then you figure out that the square root of 576 is 24. So x is going to equal positive or negative 24. In this case, which one is it? Positive 24, because we're in the first quadrant. All right, so we just did a little bit of Pythagorean theorem. Now we need to use one of our formulas. So we said we're going to try to avoid the first formula. So which one do you want, the second or the third?
Third.
The third one, okay. So I'm going to write it out. Sine theta over 1 plus cos theta. Sine theta is opposite over hypotenuse. 1 plus cos theta, which is 24 over 25. Okay. I need to combine, so I'm going to change my 1 to what?
25.
Good. 25 over 25. So I get 7 over 25 over 49 over 25, and then you can change your division to multiply by the reciprocal. What's my final answer? 1 over what? 1 over 7. Good. That wasn't bad. All right. So let's just do a little bit more practice by looking at the problems we skipped over on your Unit 5 homework, okay? 5, 6, 7, 8. A couple of you already did those problems, but you may have been relying on the key a little bit too much. So if you did rely on the key too much, you might want to try them again without the key now. So take out your homework 5, and if you haven't done the problems, do them now. If you did do the problems, let's see if we can try them again with a new understanding. Okay? So I'm talking about these problems right now, right here. Yep, I will. But this is what I want you to do next, the problems we skipped over. You're welcome.